Hello everyone, welcome to this session about data science with Python. I will be your course instructor. My name is Deepak Kapoor and I hope you all are doing well and safe at home these days. So I quickly will start with giving a brief introduction about myself, my industry experience, the industries that I've worked with, all of the clients, my technical skill set, my teaching experience and my qualification, etc. So I do have 10 plus years of data analytics experience, including data visualization, data wrangling, data science, data mining, data warehousing, etc. Since last 3 years, I'm into data science and helping various clients into the consulting environment. Currently, I'm holding a position of assistant manager at one of the big four consulting firm. I work with multiple industry clients like banking, healthcare, and retail sector. I'm Oracle certified along with SAS, Tableau, and recently completed my PSM certification as a Scrum Master. I've done my post graduation and MBA from premier institute like BITS Pilani and IIM Calcutta. About my teaching experience, I have 3 plus years of teaching experience into SAS, SQL, data science, and Python. Have facilitated and educated more than 500 students and I've taken 30 plus online and classroom training sessions. With that, I'll quickly jump on to share the agenda for today's session. So today we are going to discuss about the unsupervised learning technique and K means clustering. We'll discuss some of the real life problem statement to apply those clustering methods. Then we will run the Python based program in Jupyter Notebook environment and we will validate the results and draw the insights from the output. Okay. As we've discussed in machine learning, we do train our dataset and predict some of the outcomes, but that's a case in supervised learning model. Unlike to that, there is another learning method into machine learning, which is called as unsupervised learning model. As the name suggests, in this learning method, we do not have any labels present. So in unsupervised learning, we have a set of features x1, x2, and so on to xp measured on n observation and we do not have any of the associated response or outcome variable y, so we do not have any of the labeling present in these kind of a data formation. And the goal of this algorithm is to discover interesting pattern about all of the features measurement. It provides informative way to visualize the data. It helps discover subgroups among the variable or among the observations. Clustering is a broad class of methods for discovering unknown subgroups of data. Now we will introduce one of the important clustering algorithm with the name K means clustering algorithm. But before that, I would like to give you a brief detail about clustering methods. So clustering refers to a very broad set of techniques for finding subgroups or cluster in a dataset. Clustering seek to partition observation of a dataset into distinct groups so that the observation within each group are quite similar to each other and in different groups are quite different from each other. In other words, clustering looks to find homogeneous subgroups among the observations. It is important to define what it means for two or more observations to be similar or different. This is often a domain specific consideration that must be made based on the knowledge of the data being studied. So now let's discuss k-means clustering with the help of the whiteboard. So I'll share the example with you on a whiteboard. So as a real life problem statement, we know that let's take an example of a shopping mall. They have all of the inventory available, but it is not into the sections. So they have all of the products scattered like furniture, apparel, accessories, food items, all at one place. So all of the customers will be confused that what product is of what use. Just to make it easier for the end user or the customer, the categorization, grouping, subgrouping, or clustering comes into the picture. So we'll take one example into the k-means clustering and I'll explain you the mathematics behind it. Let's say we have one of the data set present with us with the foot length into the inches. All right. And the problem statement says that we'll have to divide those into some of the labels. Let's say it's if it's a kid shoe or if it's a adult shoe. So let's say we have observation like 2 inches, 3 inches, 4 inches, 10 inches, 11 inches, 12 inches, 20, 25, and 30. So K-means clustering work on a procedural flow by identifying the optimal value of K. Of K. And the second one is distance matrix. We will discuss all of these one by one. Third one is elbow method. And the last one is loss information, which we call it WCSS, within cluster sum of square. So let's start with assigning a random value of K. Let's say I'm saying that all of the data information I just wanted to split into two clusters. So my K will become 2 and I'll have to choose two numbers so that I can assign this as a centroid value. So I'm taking one centroid value as 5, another centroid value as 18. Now my next step is to identify all of the observations that are closer to my centroid value, which is 5. So you can clearly see that in the first iteration, I have value 2, 3, 4, 10, and 11, which are closer to value 5. And the values 12, 20, 25, 30, these are closer to value 18. So this will become your first iteration of identifying the k-means clustering. Now the next step is to take the mean value of it, which will come out to be a value 6. Take the mean value of these data points, which will come out to be 21.75. Now initial centroid value was 5, now it has been changed to 6. So in the second iteration, you'll have to change your centroid value from 5 to 6 and repeat the iteration once again. So in this iteration, you'll see that the data point 2, 3, 4, 10, 11, and 12 are closer to point 6, and data observation 20, 25, and 30 are closer to 21.75. Again, take the mean of these values, which will come out to be 42 divided by 7 as 6, and 75 divided by 3, which is 25. Repeat the iteration once again. Now this time you have 2, 3, 4, 10, 11, and 12. Observation closer to mean value 7, 20, 25, and 30. These are closer to mean value 25. Now can you see that the last iteration and the recent iteration, all of the data points are same. So at that point, when you see that the data observation and the mean values are remaining constant, are unchanged, then you can stop doing the processing. Okay. So this way you can say that your two clusters become with the value of 2, 3, 4, 10, 11, 12, which is this is one cluster, probably with the kid shoe size, and this is another cluster. This will be with the adult shoe size. All right. Now I'll explain you the same through my presentation also. Now just look at the first picture. I do have all of the data information in just one color, which is black. I do not know that what kind of a pattern or similarity or how many groups are there into this data. So my first step becomes that I need to assign a random k value, which is 3. I'm taking a value of 3 this time. So it has randomly assigned 3 centroid values in the middle of the observation. and have scattered all of the data points into three colors, which are orange, purple, and green. And it will start calculating the iteration as we have done with the shoe size example, and keep on moving the centroid information closer and the mean value of one cluster. So at the end of all of the iteration, you can see that in the final result, the clusters are grouped into a similar observation. This one is yellow color, this one is purple color, and this one is with the green color. So that was the basic fundamental of the algorithm. Now we will discuss about the mathematics behind it. All right. Now let's move on to the mathematics of k-means clustering. And the main question is, how do we decide the number of k, which we have taken as 3 in our example, last example. Okay. We have elbow method to identify k value. As we know that in all of the machine learning technique, we do have the loss information that tells us that how much of the real values are deviated from our prediction values. So within cluster, sum of square will be calculated with the distance of all of the data points to your clusters, take the summation of it, and total number of cluster, repeat the same exercise. So let's say I have 20 data points with me. If I divide that just into one cluster, my within cluster sum of square will be too high. And if I take the cluster value as the total number of observation, it will tend to be 0. So neither taking one cluster or the number of observation as the same number of the cluster will not work in our case. So we'll have to go by calculating the WCSS on a graph, and at the point where it is drastically moving to 0, we can take that point as the optimal number of k. So in this example, we can see that it's 5. Okay, now we are going to run this program on Jupyter Notebook, and as you can see that I have run all of the required libraries in it. I'm calling out the dataset, checking all of the income and age information into a graph. Now you can see that all of the information are into blue color. After running the k-means method, one array has been designed, and it has all of the information scattered into three different cluster information. You can see that for Rob with age 27 and income 70,000, they have assigned it to cluster 2. Smile with age 28 and 60,000 as income, they have given it to a cluster value 0. Now check that onto a plot, and you can see that this is not the desired outcome which we were expecting. So for that, we will have to transform that it into a min-max scalar, so that we have all of the information normalized and onto one scale to just draw the insights in a easier manner. All right, I'm going to repeat the same exercise, and now I'm checking if the centroid values are expected and closer to the mean. So you can see that the centroid values are closer and at the mean of each individual centroid and the observation. Now also calculate the elbow method and just draw a conclusion whether the random number of k which we have decided as 3, is it the right one or not. So you can see that the 3 number of cluster is the actual one after which the within cluster sum of square is tending to 0. So this is all for today's session. In the next session, we are going to discuss about other clustering technique which are hierarchical clustering and introduction to k-NN classifier algorithm along with machine learning model evaluation, accuracy, precision, recall, etc. So I would like to conclude this session what all we have discussed in today's class. It was all about unsupervised learning. Why do we need unsupervised learning and the major clustering information that we use into the method, which was k-means clustering. We have taken one example and discussed the mathematics behind k-means clustering and ran the program on Jupyter Notebook and draw the insights out of it. I hope you all have had a great learning with this session. With that, I would like to ask if you have any questions so that I'll be happy to answer those. Otherwise, see you into next session. Thank you.